Okay. Today we are going to start exception handling. That would be our next topic. Exception handling. And before I start, remember, acha, okay. First we have to do this, na? Okay. Operator. Yesterday we have seen conversions. Yes. Okay. So first we'll complete this operator overloading, and then we will proceed with exception handling. Okay. Because yesterday only one part we completed about this operator overloading. Okay, so we'll do one thing today. First, we'll complete this, then we'll proceed with our next topic. Okay, okay. So here, what I do now, I'm going to create three objects. D1, copy the same. D2, copy the same. D3, D1, D2, D3. D3 is D1 plus D, which is error now. Error. And rule is you cannot add to objects. You can add values available in the object, but you cannot add objects. Okay. Now to add the objects, we have to overload plus operator. How do you overload it? Like this. Public static operator demo operator plus and then demo object 1 comma demo object 2. Gone. Error is gone, you see. Here, error is gone. What does it mean? Whenever this line is executed by CLR, it is going to call that method. It is going to call that method for execution. So D1 reference will be copied in object 1. D2's reference will be copied to object 2. And then we say demo obj new demo 0. Now you can say obj.I is equal to object1.I plus object2.I. Return obj. So that calculated value will be stored in D3. It means now if I say D1 dot show, D2 dot show, D3 dot show. D1 show will display 22. D2 show will display 44. D3 show will display result. Control F5. Three values it will display now. Yes, 22, 44, 66. I value 22. First value I mean to say. So better I write like this. How to identify? I'll write like this. Console dot write line. First object. Second object. Third object. 22, 44, 66. That's it. What we have done, we have added two objects. Go on top. Now, same way minus, same way into, same way division, you can overload. Plus minus into division. By adding objects, multiplying objects, dividing objects, okay, subtracting objects. Okay. Now little further, if you go, Now we have next part to study in it, and that part is how to overload unary operator, that is plus plus. How to overload. So come down. Or first we'll complete this. How to compare objects. Then I'll go with unary. D1 greater than D2. Error. Change this operator. Greater than. Write if condition. If object1 dot I greater than object2 dot I, then object dot I equals to object1 dot I. Else object dot I equal to object2 dot I. Yes. Then D3 will be returned. That's the only condition I added. That addition expression I removed and added with if condition. If true, copy the value of object1 I to that local object I. If condition is false, copy object2 I to object dot I. Finally, any one of those two will be stored in obj. That obj we are returning to D3. Compile. Oh, there is error. Acha. Read the message. The operator greater than requires a matching operator less than to also be defined. It means in C#.NET, whenever we are overloading greater than operator, compulsory you should overload less than also. Though you don't have a code in it, just simply say return null matching operator. Greater than, if you are overloading, less than should be there. If you are loading equal to, not equal to should be there. If you are using equal to, then equal to should be there. Equal to combination not equal to, greater than combination is less than, greater than or equal to combination is less than or equal. Based on that, you can find a comparison. Save, build, run. Yes, 22, 44. Biggest value is 44. Similarly, equal to, if you are overloading, not equal to combination should be there. If you are using greater than or equal to, then less than or equal to should be there. So as I tried greater than, less than combination, it asked me if I don't overload. That was error for me. So compulsorily both should be overloaded. Okay. Exactly same way. Now we'll go further and we'll come up with things related to unary operator. Plus plus minus minus are there now? We'll use that. Delete all this stuff. Just one object is enough. D and write two statements. D plus 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 D dot show. Go on top. Now I write here. Now what you write is uh, then demo operator plus plus demo D dot I plus. return D. Yes. Now D plus plus is also error gone. Plus plus D error is also gone. It means for both the increments, same method is going to work for us. For both the things I'm saying, post and pre for both. So it means how much is you given I now? 22. D plus plus increments I as 23 and plus plus I increments your I by one more plus one. So it means finally D dot show will return I value as 24. Control F5. I value is 24. Yes. Now, keeping these things in view, these are examples that which mostly they ask in technical round, especially in system testing and all. They'll ask you to write coding for this. So one is they may ask you to write matrix multiplication program using this one operator overloading or matrix addition using operator overloading. Right, you can try actually, like you try the program for matrix multiplication by overloading star operator. You do the program. It will be really interesting program, but go for it. Try. That's it. This is how you overload an operator. Two programs for your assignment. One, write a program to perform matrix addition by overloading plus operator. And another example, write a program to perform matrix multiplication. Just give me 1 second. So this is how you work with the operator overloading. And those two programs you can do on your, I mean, you can try out for matrix addition using by overloading plus operator and multiplication by overloading star operator. Okay, right. The next topic what we are going to start is exception handling. Exception handling. And in that, first to remember is errors are classified into three types. Errors are classified into three types. One is called compile time errors. One category. Compile time errors means those errors which occur at compilation of a program. It will provide errors for those instructions which basically happens due to syntax mistake. If you do syntax mistake, then you'll get that. So you can call this compile time errors as syntax errors also. And second category is logical errors. When I say logical errors, it is something like a required output and generated output. It means the output what you need and the output what your program provides. When they don't match, then it is called logical error. For example, if you have written a program to check whether a given number is prime number or not, when I'm giving prime number, it is saying it is not a prime number. When I'm giving not a prime, it is saying it is a prime number. It means program is going to my requirement in a reverse. So definitely somewhere there is a error in the program. There is a logical error in the program. So that logical error you have to rectify and you have to. Okay, second category, it's called logical error. Third category is called runtime error. Runtime errors means those errors which occur at the execution of the program. At the execution of the program. And because of these errors, program always in between gets terminated. In between gets terminated. So it is called abnormal termination. Abnormal termination. And to handle those errors, we have been introduced to work with exception handling. So altogether, three types of errors: compile time errors, logical errors, runtime errors. So obviously, exception deals with what then? Runtime errors. Exception deals with runtime errors. And how many types of exceptions that we are going to learn? Answer is two types: built-in exceptions, customized or user-defined exceptions. Built-in exceptions, customized or user-defined exceptions. And we are going to use four keywords to work with exception handling. Four keywords: try, finally, catch, throw. Four. Right. So let's see each block. How do it work? First, I'll write a basic program. Console dot write. Enter first value. Int equals to int dot r console dot read line. Console dot write. Enter second value. Int b equals to int dot console dot read line. Second one. Console dot read line. Second statement. Now, I just try to write a code for dividing two numbers. I write the program. What's the aim of the program? Is it dividing two numbers? That's what your aim is. Okay, now I write here integer c equals a by b. Console dot write line. Quotient is plus c. Plus execute. Five, two, two. Okay, normal execution. Rerun again. 5, 0, error, unhandled exception. Unhandled exception. divide by zero exception. Attempted to divide by zero. Every message has been displayed. Okay. Now, if at all in the same program, if I make changes and if I change to float, int, change to double, float, anything. So I'll go for float. If I replace, done. Wherever int, I've changed to what? Float. Run the code again. First value, 5. Second value, 2. Now answer is 2.5. Rerun again. 5, 0. This will end up with error. Usually, so just now when I demonstrated for integers. But we come to a conclusion. And that conclusion is whenever you divide a number by 0, whenever you divide a number by 0 for all integral values, for all integral values, it is runtime error. Whether I use int or I use byte or I use long or I use short or I use uint, u short, u long, u byte, s byte, s byte, not u byte, s byte, signed byte. So any of these integral data types I use, that will end up with runtime error. But if it is a case for real and double, so if it is related to what now? Float and double, especially for these two cases. Just now I demonstrated when both were numbers, we got the value as 2.5. But now I wantedly give first value as 5, second value I give 0. Now dividing a number by 0 for floating point is never runtime error. Never, never, never you get runtime error. Rather now you get a message, quotient is, quotient is, you get infinity. Yes, infinity. If I run again, -5, 0, negative infinity, minus infinity. If I run again, if I say 0, 0, nan, not a number. Positive infinity, negative infinity, nan, not a number. Now another approach we have. Instead of getting this built-in data for positive infinity, negative infinity, nan, you can substitute your own messages also. That option also we have. Your own options. How would you do like for your own options? What we are supposed to provide for that? So you can say like this. You can add if float dot is positive infinity of C, you'll get a message. Acha, that okay, okay, okay. This is negative, I guess. It should be positive. If condition, anyways, you write is fine. Why to change? Is positive infinity. Okay. Console dot write line. Positive. This is negative. Third case. Else. If float dot is nan of C. Console dot write line. Not a number. Else. Quotient is. Not try. Save. Control F5.
मेरे को यार पहले मार लगा फिर यार एक नया गेम डाउनलोड करे मैं उसको खेला तो फिर से मारा खाया मैं आज नहीं खाया
5 0 positive infinity. Control F5. Minus 5 0 negative infinity. Control F5. 0 0 not enough. Now you don't get your built-in messages. Rather, our messages have been produced for the output by using these methods. E is negative infinity, E is positive infinity. Okay. Now question that comes, where is exception handling in this part? Okay. Now I will introduce. Delete all this code. Replace float to int. Done. Yes. Now run again. 5 0 divide by 0. Runtime error. What is your aim now? You don't want to come across, or you don't want these runtime errors to terminate your program. That is what your aim is now. Program should not be terminated. Program should not end. Abnormal termination. Program should not end with abnormal termination. So for that reason, I introduce try. Block open. Come down. Close the block. Yes. Remember, try is called multiple statement block. What you are going to do? In try block, we are going to monitor all those instructions in which runtime errors are expected. Try means you're checking, may or may not. If you come across, do something. If you don't come across, that is fine. But now, if you compile, you would see very clear one message. Build. Yes. Message you see. What is the message? Expected catch or finally. Means try block should have either finally or catch. So what I do, I'll write finally. And dot write from finally block. And remember one thing. What is it? What is that you remember is finally is such a block in C# under exception handling which goes with 100% execution. Finally block. 100% execution. Why I said 100% execution? Means even though your program has runtime error, CLR will execute finally block for sure. And another point is whether you have runtime error or you don't have runtime error, finally block is executed. Confirm it is. So now we are just trying to understand basic things of finally, but we have a lot to study about finally even in my coming classes. Coming classes. Chalo, right. I'll show you all the things. First compile to see whether you have error or not. No. So it should be successful now. Yes. Succeeded. Run the code again. 5, 2, okay. Finally block. Executed. Error you create now. 5, 0. Program is terminated, but even though it is terminated, before closing the program, finally block is executed. It means finally block will be executed when at least one line of that method is executed. One line of that method is what? Executed. Okay. And rule for finally block is a try block can have maximum of only one finally block. Only single. You can't write two finally blocks. I'm writing two finally. This time you'll get a message. Expected try. Compile. Try expect. Yes. Syntax error and message try expected. Why? Because this is combination over. Try finally combination over. Now C# is feeling that you have written finally without try. For that reason we got that message. Expected try. So now in this, we have try and finally combination. Now, another important thing is after try, finally, I'll introduce catch block. I'll introduce catch block. So I write here catch exception divide by zero exception e object put a message console dot write line cannot divide the number by zero. Yes. Now compile same message. Try expected. Expected try. Yes. Now I come with a conclusion. Catch cannot be after finally. Remember that point, please. Catch block cannot be after finally block. Rule is what? Try catch finally makes point. But try finally catch not allowed. So it means finally will be always the last block in the program. Last block. So now if I go with reverse, like first catch, then finally, yes, valid. Yes. Cut this code. Now execute. 5, 2, control F5. 5, 0. Yes. Now catch block message you find. Cannot divide the number by 0. That is what I have written. Yes, this message. So related to finally, now you remember two things. One, for a try block, only one finally is allowed. Only one finally is allowed. And second point, finally should be always at last. Finally should be always at the last. Finally. How many finallys you will write? Only one. And where do you write? Always at last. Okay, another scenario. Now I run my code. I'll give first value 5, second value mistake I'm doing Ahmad, wrong, format exception. So this also I'm supposed to handle now. So I introduce catch format exception e object console dot write line wrong input 5. Okay, this is for divide by 0. 5 Ahmed, wrong input. Wrong input. Okay, I'll do one thing. I wantedly will create two errors in the program. Console dot write enter n value integer equals to int dot console dot read line. Create an array int equal to new int and I simply display length. array dot length. That's it. Control F. Listen carefully to this code what I'm trying to cover. I'm supposed to give three inputs. I'm supposed to give three inputs: 5, 0, minus 7, or Ahmed. What are the errors you have now? Or minus. Better, I'll give first negative, I'll show you. Yeah, minus 5. Now you get a message. Overflow exception. Why? Because rule. Array size cannot be negative. But you won't get that message in that way. Rather, you'll get a message saying that overflow exception. Now, if I input minus 5, enter. Yes. First error, cannot divide the number by 0. Second, I should get overflow, but you didn't get that. You didn't get. Okay. Do individual, you do know. Individual. 5, 2, minus 5. Overflow exception. Line number, method name, exception name, error message, everything we got. Okay. Do one other mistake. 5, 2, Ahmed. We have exception for this. Yes, wrong input. So now I come to a conclusion that I introduce overflow as well in catch overflow exception E console line. Array size cannot be negative. Control F. Array size cannot be negative. Okay. 5, 0, minus 7. Actually, two errors are there in the program. But we come to a conclusion that one try block is going to handle only one exception. One try block will handle only one exception, maximum of only one exception. Even though your try block may have three errors, but it's going to handle only one. It's going to handle only one exception. And another interesting thing here is this overflow exception, format exception, divide by 0 exception, all these are classes, built-in classes. And plus, these all are child classes. Overflow exception, format exception, divide by 0 exception, all are child classes. Child class to which class? System dot exception base class. System dot exception base class. Okay. So all these are what you said now, child classes of which class? System dot exception class. As far as C# is concerned, we have around approximate, I'm saying approximate of around 400 plus exceptions in C#. 400 plus. Obviously, it is impossible to learn all in training part. That is the reason whatever we learn are important points to understand exceptions. So in future also, whenever you come across with any runtime error, you have to follow these rules. You have to follow these points to handle the exception. You have to follow those rules and you have to follow those points for exception. That is the reason I don't say that you'll be made to learn all 400 plus exceptions. No. Sometimes, as far as my experience is concerned, you are 10 plus years of real time exposure to .NET. Still, you may not be covering even 50, 60 exceptions of it. 50, 60 or more, I'm saying. More. Hardly 15, 20 exceptions we come across. So few you come across only when you when you get that error in your program. Otherwise, you may not be able to identify that exception. Okay. So what did I say now? How many exception try block can handle? Only one. How does it handle? Whichever occurs first, that would be handled. That would be handled. Any one it will handle. Try can have how many finally blocks? Only one. And it will be where last to try block. How many cache blocks a try block can have? A try block can have one or more cache blocks, but only one finally block. Okay, do you understand? Okay, there are still some more things, points to learn.